Okay, so this is laboratory number 4, pulmonary volumes and capacities, and I have a little note here in red. Please bring a USB device to this lab. You're going to need a USB device to pull off the information from the computers that we have here. We're going to be using the new BioPack systems. We're going to just make some tables, have your information on the computer, and you're going to want to be able to pull those off so you can include them in your lab report. So please bring a USB device to this lab. So the first thing we're going to look at are the 4 volumes and the 4 capacities. So this graph can be kind of intimidating when you first look at it, but there are some things that might be kind of intuitive to us. So first of all, the x-axis, actually there's no x-axis, the y-axis is the lung volume, right? And we can see it goes from 0 to 6,000, that's milliliters, right? So that'd be 0 to 6 liters. And this is just the lung volume that you can fill with air, right? And now some of the terms that might be intuitive are the tidal volume and the total lung capacity. And those are the 2 terms that you see all the way to the right of the graph here. So tidal volume is just the air that you breathe during quiet breathing. And the total lung capacity is all the air that can fit in your lungs. So those 2 terms might be kind of intuitive. Everything else might be kind of confusing. So we'll look at the definitions of all these terms right now. So the volumes, let's start off with tidal volume. Again, just the volume of one breath during quiet breathing. Right? We can see that's just the amount of air in that little yellow section. So we use very little of our lung capacity during quiet breathing. Now the inspiratory reserve volume, the IRV, the volume you can inhale with maximal effort, right? So I'm filling up my lungs with as much air as I possibly can. You can kind of see that in this graph. So inspiratory reserve volume is in the purple. You can see it right here. So I have my tidal volume here. That's just the breathing during quiet breathing. But then if I take a maximum inhale, I fill up my lungs. That's the IRV, inspiratory reserve volume. Conversely, the expiratory reserve volume is the volume you can exhale with maximal effort. So I'm breathing normally, and if I breathe out as much as I can, you kind of can feel your abs get tight and you're trying to push out as much air as possible. That's an exhale with maximal effort, right? So that's the ERV. And then the residual volume is just the volume remaining in the lungs after a maximum exhale. So even though I just try to exhale as much air as possible, there's still going to be some air left in there. Okay, so that's the residual volume. So if we go back to the graph, we can see that even if I have my expiratory reserve volume, I just try to blow out as much air as possible, there's still going to be this residual volume, right? So there's still going to be some air left in my lungs. All right, so those are the 4 volumes that you might see during this lab. Now the 4 capacities are, the first one is vital capacity, right? And you can see that there's some equations that kind of tell us what vital capacity and what all the capacities are. So we see that vital capacity, VC, equals ERV plus TV plus IRV. Right, so if we go back to our graph here, that equation might not mean much to us, but we can see vital capacity is pretty much all the air that we can use in our lungs. So it goes from a maximum inhale all the way down to a maximum exhale. Right, so the VC equals the ERV, right, plus the tidal volume in the yellow, plus the IRV. Right, so the vital capacity goes from the purple, the yellow to the dark blue, and those 3 sections are the ERV, the TV, and the IRV, right? So simple equations to relate the capacities to the volumes. So the next thing that we should look at is the inspiratory capacity, and that's IC, and that equals the tidal volume plus the IRV. So again, going back to our graph here, we said the IRV, inspiratory reserve volume, plus our tidal volume, right? And that's our inspiratory capacity, right? We can see that right here. It goes across the purple and the yellow, okay? And then there's an equation for the functional residual capacity, FRC, equals the RV plus the ERV, okay? So he says the ERV plus the RV, the expiratory reserve volume plus the residual volume equals the functional residual capacity. So you can see that these 2 added together equals the functional residual capacity. And finally, the total lung capacity is residual volume plus the vital capacity, right? So go back to our graph one more time. Total lung capacity is all the air that you could possibly fit in your lungs, right? So we go from 0 up to 6,000, and that is simply your vital capacity, which we see is all the air that you can use, plus your residual volume, right? So vital capacity, all the air that you can use, plus the residual volume that will always stay in your lungs no matter how hard you try to blow it out. And that is your total lung capacity. And again, if you want a better definition of these terms, the definitions are in a table in your textbook, pages 206 to 208, short reading, and there's a table that just gives you the expected volumes of all these and gives you a hard definition of what all these volumes and capacities mean. So check out that table, pages 206 to 208, again, 3 pages, fairly simple reading. So check that out if these terms are getting kind of confusing. So another thing we can look at is the FEV1. The FEV1 is the force expiratory volume in 1 second. So anytime you hear FEV, it means forced expiratory volume. The FEV1 is the forced expiratory volume in 1 second. So you can see in this graph here, we have an FEV1. So in 1 second, this person was able to blow out a pretty good portion of air. If we said that this was liters, which is volume in liters, that, let's say it's 3.5 liters of air, and they did that in 1 second. And you can see that their max, or their FEV6, so after 6 seconds, this is all the air they could possibly blow out, was maybe about 4.25. You see that they got a lot of air out in 1 second, right? Their forced expiratory volume in 1 second was quite large compared to their total air that they expired, right? And so for a healthy individual, it looks like a healthy individual. Healthy individuals usually have an FEV1 around 80% of their vital capacity, right? So it looks like in this test, they tested it for 6 seconds. So this person blew out as much air as possible in 1 second, and then from second 1 to second 6, that's when they're really trying really hard to get all the air out of their lungs. So like, so that's just how that test is done. And so again, the FEV6 in this test would equal the vital capacity. Okay, now an unhealthy individual, maybe someone who has COPD, chronic obstructive pulmonary disease, will have an FEV1 less than or equal to about 33% of their vital capacity. So that's a very big difference. So they'll try to blow out as much air as possible, but since they have a certain pulmonary disease, they won't be able to get it out. Okay, and so this is an easy way to diagnose any kind of disease that is related to the pulmonary function. So this is a typical pulmonary function test. This is a very simple test, and this is something that we're going to be doing in our lab this week. So you just breathe into a device. As you can see, for some of it, you're just sitting there, and the test takes about a minute. So if you want to be a participant, this is definitely an easy lab to be a participant in. And we'll have our computer set up, and we'll be able to see the volumes that you produce during your test. So again, the purpose of a pulmonary function test is a fast, easy method to diagnose conditions. We have a list of conditions that we can diagnose that are related to pulmonary function, asthma, COPD, chronic lung disease, and there are many others, even Duchenne muscular dystrophy, which is related to muscle atrophy. Your muscles not be able to work, especially your muscles related to pulmonary function, like your diaphragm and other muscles around your lungs that can be atrophied and will affect pulmonary function. So it's not just a test for older people that you might think, okay, chronic obstructive pulmonary disease, usually older individuals have that. This test is actually useful for other people, pediatrics, who are looking at Duchenne muscular dystrophy or other dystrophies that are related to pulmonary function. So it's a fast, easy method to diagnose a few different conditions. Alright, so the methods for this lab, you're going to work in small groups. We're going to have different setups in the lab. We're going to have 6 computers, so we'll have multiple groups. Follow the BioPack on-screen instructions. It's fairly simple. You have to do some calibration with the system, but it's very quick calibration, and then the test is very easy. usually maybe 1 or 2 minutes. If you're just doing the resting portion, it'll be 1 minute. The exercise portion is 2 minutes. So again, we're going to record data for 2 individuals. Both of them are going to do a resting part, and then they're going to do 2 minutes of exercise. All right. So at the end of the day, you're going to have 4 sets of data. Right? You're going to have the 2 individuals. They're both going to do a resting condition and then an exercise condition. Again, it's going to be fairly short, and they're just breathing into a device that can measure the volume of air that they're breathing in and breathing out. Alright, so now after you've done all the breathing recordings, you save each recording, and then you can analyze the data. So when you analyze the data, you're just comparing the different volumes, and you'll be able to see a graph that shows the volume of air that they've breathed. Right, and you're going to use those volumes, and you're going to use the recordings to fill out this L12 data report sheet for your calculations. Now, the L12 data report is a data report sheet that shows up on the BioPack device. It's just a report that has, name, age, date, all that fun stuff. And then there's going to be a table. The main table that you want is table 12.2. And that's the table that you're going to fill out that has all the calculations for your vital capacities, all your capacities and all your volumes you can calculate and you can put into that table. Okay, so a little bit more detail about the report from BioPack. You can analyze your data, enter your calculations into this L12 data report. You can find this data report. It's under the Help tab, and then you just go down to L12 data report, so it's easy to find. And then you can see that there are some tables there that you can enter information into. So you're going to want to perform some calculations. There's a calculation for predicting the vital capacity of the subject based on age and height. And then you're going to do the calculations for the 4 volumes and the 4 capacities that we talked about earlier. You're going to enter all the data into table 12.2. Right, that's the table that's going to have all the volumes and capacities. So do the calculations and fill out that table. Save this table, save the data onto your USB drive. This is the data that you're going to want to use to include and put into your lab report that you submit on Spark to me. All right, so you're going to take the table 12.2 and the data in the data report, and you're going to save it onto your USB drive and then use it and put it into your lab report for this lab. So again, place the table into your lab report, and that will be part of your lab report for this week. And so some final things about the lab report this week. It's a short form lab report, so just results and discussion. For the results, there's going to be some sample calculations for 1 subject, and then table 12.2 from the data report that I've talked about, and then the discussion questions as usual. Okay, so it's a short form lab report, results, and discussion. And that's about it.